Welcome everyone in a new episode of the Monthly Dev. This is the episode number 41. So we have been doing this monthly for 3+ years. And today we'll talk about mostly testing, I'll say. And before we can start, I would like to make a quick sound check if all the speakers are here. Filip and Marcus, are you there?
Hello.
Okay. I think you're muted, Filip.
Yeah, I'm here. Sorry.
Perfect. No worries. Sometimes it happens also to me. Like I start this event like muted, but this is what happens in live events. And yes, so before we start, I want to say that these events, of course, are sponsored by daily.dev, so you can check it out. We have also a very nice giveaway to win a kawaii t-shirt. We are selecting a winner every day for 30 days for the whole period of June. You just need to refer a friend, and that's it. Do you ever do live talks? I do. Okay. So before we start, I usually start making a question, which is like to the speaker, in case have you ever tried daily.dev? And then I think we can start. If any of you have ever tried it, otherwise we can just skip.
Actually, I installed it a couple of days ago, and now every time I open a new tab, I see all the latest news. Let's see if I stick to it.
Nice. So we have a new user. Really happy about that, Marcus. Thank you so much for giving us a chance. I would say thank you so much. We met with Filip some days ago. It was a coincidence. Filip, your experience with daily.dev? You ever tried it?
It's been nice. I have won one of the giveaways. So to all of the people are watching, make sure you join, because they have some really nice merch. I won a Snakes and Ladders game, and it looks like a lot of fun.
Okay, now I can say that joining daily.dev because of the swag. The swag level of daily.dev is really over the top, over the 1,000. Okay, perfect. Okay, nice. So I think we can start. So we planned with 3 speakers, but maybe we have to go with 2 of them. So maybe we'll have a little bit extra time. So Marcus, if you have something else to say, we can have some more time. I need to kick Filip, and Filip, I'll see you soon. Okay, bye. Nice. So we have Marcus Uberleiner. I don't know, I forgot the pronunciation.
Okay.
And please introduce yourself. You are a senior full stack developer. And so please, quick introduction, quick spoiler and trailer of your talk, and then we start.
Okay. Yeah, as you already said, Marcus Oberlehner is my name. And up until recently, I was working as software architect, but now I'm switching roles, becoming a full stack front-end engineer or full stack senior engineer again. And besides that, I write a lot of blog articles about web dev stuff, but also some other stuff. And in general, I think a lot about how to most effectively test web applications. And this will also be the topic of my talk today. And in the talk, I want to highlight one particular kind of applications and how we can test them most effectively using techniques from contract testing.
Nice, perfect. So when you want, you can start sharing your screen. So usually we have like 20, 25, 30 minutes for the talk, and then we'll have a Q&A session. So this is usually how this is structured. So there we go. No more mocking. And Marcus, best of luck, and see you in about 25, 30 minutes. Best of luck. Bye-bye.
Thank you very much. Okay, yeah, so as I already said, my topic today is about contract testing in part, and particularly about how we can write better tests for server-centered rendered applications that get their data from microservices. So a couple of years ago, my colleagues and I, we started to work on a completely new application, and we had to think about a completely new stack. And at the time, it was the newest thing were single-page applications. And so we thought, yeah, let's go this route as well, and let's build a single-page application. And we chose Vue.js for it, but for the matter of this talk, it doesn't really matter the exact front-end technology. But what was important was that we had our single-page application talking to microservices, to multiple microservices to get its data. And this was all nice and good. And the nice thing about this single-page application architecture, especially when talking about testing, is that we can test our single-page application very easily in isolation. So for testing this part, this application here, this client-side application, we can simply mock all the requests to the services. So from this perspective, this was nice. But as the years passed by and as our system matured, we realized that this architecture wasn't really the best for us, because we only had this client-side rendered single-page application and microservices. But there were a lot of things that we wanted to do server-side, but we couldn't really do them in the application part, so we had to do them in the microservices. And this wasn't really the right place to do those things, especially when we talk about authentication and things like that. So what we decided a couple of years later was that we want to go a different route with our application architecture. So we switched to something that looks like this, where we have now a client-side part and also a new server-side part. So a backend for front-end for our client-side application. And this was a lot better for our overall architecture. So now we could do things like authentication, for example, on the server-side part here in the application itself, and could keep our microservices cleaner. But now we had a problem with testing, because previously we could test our application in isolation and simply mock the requests to the services. But now we had two kinds of ways of how we fetch data. So first of all, our single-page application fetches data now from this backend for front-end part. But then we also have this requests here, which are server-to-server requests. So we have two kinds of requests here. First of all, we have the client-side request to the server, which we can mock, and those requests here, which we can't. And this was a problem for testing. So we had to think about a new way for how we can structure our tests so that we can test our whole application again and don't have to mock the requests made from one part of the application to another part of the application. But before I go into the details, I want to take a step back and look at how we did, or how we approached testing, or how we still approach testing with different architectures like a monolithic application architecture, so we can better understand what's important and why we can't do it the same way with an architecture like we just saw. So with a monolithic application, this can be, for example, a modern stack like Next.js and Nuxt, so a modern JavaScript-based stack, or a little bit more traditional PHP stack with Laravel or Rails even. But the important thing here is that we have a database. So either technology we use doesn't really matter. The important thing here is that it's server-side rendered and we have a database. So we have a monolithic application where everything from the application logic to the data logic, everything is in one big monolith. And in this case, we can use database seeding for testing. And many of the frameworks like Laravel, for example, have database seeding already built in. So, and here we see again how it works. So we have our test for the monolithic application, and we have a database where we get all the data. And for the test, we can seed the database with just the data we need to make a particular test run. And As I said, in frameworks like Laravel, we have this already built in. So when you create a new Laravel application, you get the seeding functionality to quickly set up seeder classes, which you can use to write your tests. So if you want to test that it is possible, for example, to add an item from a to-do list or shopping list application, then you can use your seeder class to seed your database with some items, and then you can check if you can remove it. And similarly, if you set up your application with Nuxt.js or Next.js, you can use something like Prisma as your ORM, and there you can use Prisma to seed your database with the data you need to run your tests. Okay, so with a monolithic application architecture, we can solve testing and having the right data for our tests with database seeding. So we have a test testing the whole monolithic application. We seed our database and everything is fine. Now let's take a short look how this looks in single page applications. We already saw this at the beginning. With single page applications, we have also one application block here, which we can test which we can test in isolation with our tests, and we mock all the requests to the microservices. And this might look like something you can see here. For example, when using Playwright to write your tests, then you can mock requests to a particular endpoint, for example. So let's say you get all the items on a shopping list application from a microservice under /API/items. Then with Playwright, you can say, whenever a request is made to this endpoint, then we want to return this data and don't make the real request to the microservice. And we can do this because those requests are made from the browser to the server. But now let's go back to our initial problem. Now, what do we do when we have server-side rendered applications that get the data not from a database, but from microservices? So what can we do in regards to testing when our architecture looks like what you can see here? This might be a Next.js application or a Nuxt application or even a Laravel or Rails application. Doesn't really matter. The important thing here is that we have a client-side part and we have a server-side part, and the server-side part is getting the data from multiple services or over HTTP requests, for example. So in this kind of architecture, now we have two types of requests. First of all, we have browser to server requests. So here the client-side part, for example, in the Next.js application, this would be the React part, your React components and stuff like that. The client-side part makes a request from the browser to the server-side part, to the BFF part. And this is a Node.js server typically. And now the server-side piece here then makes server-to-server requests to the microservices. And why is this important to note? It's important to note because with tools like Playwright and Cypress, we can only mock those kinds of tests. We can only mock browser-to-server requests. There is no way in which we could mock server-to-server requests with tools like Playwright and Cypress. So when we want to test a server-side rendered application, like you can see here, which gets its data not from a database, where we could use database seeding, but microservices, we have to find a different way how we can test this whole thing. And one way would be that we split it up in those pieces, that we say we have this client-side piece, and we can write tests for only the client-side code. Then we have the server-side piece, and we write tests only for the server-side stuff, and we still use mocking with Playwright to mock the requests from client to server, for example. And of course, we also have separate tests for all of our microservices. Okay, so technically, we could absolutely do it that way. But the problem with that, at least in my opinion, is that now you don't have any way to guarantee that your whole system works all together. So although you might have perfect test coverage because you have tests for every piece of your system, you really don't know if you put everything together, it really works. And one way to make sure that it still works even when you put all the pieces together is by contract testing. So with contract testing, we can specify a contract and both provider and consumer adhere to this agreed upon contract. And the provider can be a microservice, for example, and the consumer might be another microservice or our application or multiple applications, for example, multiple web applications and also native mobile application. But all agree to one contract. And the contract can have different formats, but with the tool I use for contract testing, which is called Specmatic, you can use OpenAPI specifications, which you can see here. And OpenAPI specifications you can write in a YAML format, as you see here, but you can also use JSON if you like. But in this case, it's a YAML format where we specify how our service is called, what it does, and which endpoints it provides. And here we say we have a /products endpoint, which listens for GET requests and by default returns a 200 code and a list of products. And it returns a JSON structure with arrays of items, and those items are products. And as we can see here, we can also specify in this OpenAPI specification how a product might look like. This product might have an ID, which is a UUID, and it might have a name. And when we create products, the name is required. And that way, we have our contract, which we can use for contract testing with Specmatic, for example. So with contract testing, what we could do is that we define a contract between the client-side part of our application and the server-side part. And then we could use tests to validate that both pieces adhere to this contract, and then we can ensure that they will work together as well when we put them together in production. And although this makes a lot of sense for this barrier here, so when you want to ensure that your application, or at least the server-side piece of your application, will work with the services that are deployed on production, then contract testing is exactly the right tool you should use, and I highly recommend you use contract testing for this. But in my opinion, to validate whether our client-side piece of our application and the server-side part work together, and keep in mind this is one single application, I don't think contract tests are the best way to go forward. But still, what we can do is we can use the artifacts of contract testing, which are the contracts, to write better tests for our server-side rendered Next.js application, for example, as well. So what I recommend you to do is to don't separate client-side and server-side pieces of your application, but test the whole application as one thing. And instead use the contract you get from contract testing between your application and your microservices to run a stub server using Specmatic. So Specmatic allows you to run a stub server, which you can then control during testing. So when you have a test where you require your to-do list app, for example, to have to-dos already in the list, then you can tell the Specmatic stub server to show a list of to-dos. And then when you have another test where you want to ensure that if there are no to-dos yet, that there is some button that that asks you to create a to-do, then you can tell the Specmatic stub server to show no to-dos. So the service should return an empty list, for example. Okay, so let's take a look how this looks in practice. So how we can use an API first approach. So API first means that we first write our OpenAPI specification and then use this specification to run a Specmatic stub server. So let's dive into the code. And for this, I have an example repo with two projects. One is the service, the microservice, a product microservice, and the other one is a shopping list application, which in this instance is a Next.js application, but doesn't really matter. It could be a Next application, it could be a Laravel application, whatever. Any server-side rendered application that gets its data from microservices. So as I said, we want to practice API first, and what this means is that we first start with the API specification in the YAML format. And we already saw this in the slides. Here we have our product service, and it has a path /products, and it listens for GET requests, and when a GET request to /products is made, it returns an array of products, and when a POST request is made, then we can create a new product, and the product looks like what we specified in here. Okay, and now we have our specification, and at this point, as soon as we created this specification, both the server-side or the backend guys and the front-end guys can start working on the implementation, because they both agreed on how the API will look like. And of course, we practice TDD, and this means we start with the test for our new shopping list. And here I have prepared a shopping list specification file for the test, which is written with Playwright. And to control the Specmatic stub server, it provides an endpoint, an expectations endpoint, where we can tell the stub server whenever a request is made that looks like this. In this case, whenever a GET request to /products is made, it should return the following data. In this case, two shopping list items. And whenever a POST request is made to /products, it should return that data. And when another GET request is made to /products, it should return all three items. So also the newly created items, because we want to test that we can add a new item to the shopping list. And other than that, it's regular Playwright code. So we can say, go to the homepage where the application is located, then fill out the name field, so enter butter in the name field, and press the add item button to add the new item to the shopping list, and then we expect that new item on the shopping list. And we can run this to check if it works, but first we need to start the Specmatic stub server. So for this, I go to the service product. Oh, sorry. I go, oh, what did I do? Oh, I stopped sharing screen.
I think maybe you stopped sharing. Sharing the screen. It's okay. No problem. There you go. Fixed in production. Bye.
Fixed in production. So yeah, sorry for that. Okay. So now you see the code again, and we go to our terminal, and you can see we are in the service product project, and in here we have to start the Specmatic stub server, and we can do this by running Specmatic stub and then our specification file, our YAML file in this case, and just by that we run our stub server. So now when we make requests to the stub server, it will return with the data we said it should return, and by default it will return some random data that matches the format of the specification file. And next, we can start our Playwright tests. I start them in UI mode so that we can see what's going on. So here you see Playwright and the test. So let's run it. And when we go through it, we can see we open the page and we already see two items on the page because we told the stub server it should return the milk and the bread items. Then we fill out the name field and add the new item. And when we add the new item, we refetch the list of data, and the stub server returns the 3 items now because we created a new item. So now you might say, yeah, that all looks nice and good, but actually the test looks pretty ugly because we have a lot of stuff that's not really important for our testing here, and you're absolutely right for saying that. So what I recommend to do in general, also for mocking and stuff like that, is that you come up with your own abstraction layer. I call it a DSL layer, so a domain-specific language. Domain is, in this case, is the domain of a shopping list, and we want to create our own language, what we can do with our shopping list. And in this case, I abstracted away the expectations endpoint calls by defining an has items function here, so we can see, say, in our test it has items. Then the same for we have a can add item function where we tell the stub server that it should be possible to add a new item. And then we have our DSL where we say for our shopping list, we want to be able to open the shopping list. When we open the shopping list, by default, it should have items. So we call the has items here, and then we open the shopping list. We also say we want to be able to add new items to the shopping list. And for when adding new items, we need to tell our stub server it must be possible that we can add items, and that when the next request is made, it should return the default items with the newly added items. And then we can input the new item and create it. And then we also have the possibility to expect an item on our shopping list. And with this DSL, we can write a much cleaner test, as you can see here. So in this test, it's the same test as before. We say it should be possible to add a new item to our shopping list. Then we say, for this, we want to open our shopping list. Then we add the item to the shopping list, and then we expect the item to be on the shopping list. Okay, so with that, I think I need to stop sharing real quick because I have closed my browser with my presentation. Just a moment.
I'm here to the rescue if you want, Marcus. We also have a couple of questions for later, so I don't know how much left you have. You are basically almost done with your time, but if you want to share again.
Yes.
Okay.
Okay, so with that, it's just for the last 2 slides, but you have to see that. So with that, with using the API first approach and then defining contract tests and having the stub server, that way we can write better tests with the help of those contract tests. Thank you very much.
Okay, perfect. Thank you so much, Marcus, for your presentation. I think we also have, of course, the compliments here. So thank you, really appreciated. We have a couple of questions, and in the meanwhile, you can also drop more questions. So we have one question by Daniele Grimaldi. What software do you recommend to test a front-end web application?
Yeah, so in general, there are a couple of good tools you can use. So if you want to run your tests in a real browser, then Cypress and Playwright are the way to go. Personally, in recent months, I mostly use Playwright, but there's also nothing wrong with Cypress, so it's a matter of taste, I think. And for component tests, there is some debate if you also should use Playwright and Cypress. So with Playwright and Cypress, you can write your regular tests and your component tests. You can do that, but I personally use vtest mostly for component tests. And for unit tests, for testing Node.js code and for testing smaller units of code, I highly recommend vtest.
Thank you. Yeah, so we had Debbie O'Brien, which is a huge advocate of Playwright here a couple of times, but of course, thank you so much. We have one more. By Noel, what are the pros and cons of Specmatic as compared to Mountebank and Wiremock?
I'm personally not familiar with the two other tools, but I can say what's great about Specmatic, for example, compared to Pact. Pact is another big contract testing framework. And what I really like about Specmatic is that it relies on OpenAPI specifications. And you can, I'm not quite sure, like with WireMock, I think I heard it already, but I'm not quite sure if WireMock really can do contract testing. So in this talk, I didn't really show the contract testing capabilities of Specmatic, but what this enables you to do is to ensure that your backend service matches the OpenAPI specification. So yeah, I'm not quite sure if it's better than the other tools or if they are the same league, but yeah, Specmatic is cool because you can use standard OpenAPI specifications for contract testing and stubbing and stuff like that.
Thank you so much, Marcus. We have one more question, so I don't know if you want to check it later, but now we have to kick in the next speaker. So if you want to check the YouTube chat, probably will get an answer.
Yeah, I will check.
Thank you so much, Marcus. Really appreciate it, and yes, best of luck with everything. Okay.
Thank you.
Bye. Okay, we made it. Hi, Jessica. How are you? How's it going?
Hey, good. Let me make sure that my audio is keyed in properly. Cool.
I can hear you. You can check in the settings if it's the correct microphone. Sometimes we have like 3-4 microphones that we need to select.
All right, we're gonna do it on the non-fancy one. All right. Cool.
Okay, perfect. So welcome, Jessica. And I think this is the first time that we actually interact in this way, because maybe because we interacted a bit on Twitter, but you work at Ionic, right?
No, I just changed jobs, and I haven't made an announcement yet about it, and I keep.
So in this video, you will have the no.
Yes, in this video, I will say where I work now and where I'm at.
Perfect. So
and then I have to update my website.
Okay, perfect. No, I'm sorry, but the tech moves so fast that by the time we create the event, things change. But it's fine. Okay, nice, Jessica. So let's please make a trailer of your presentation, and also, of course, introduce yourself. And then when you want, you can start sharing your screen in the background.
Okay. So my name is Jessica Sachs. I work at Hero Devs now. Hero Devs has a few ways of explaining what they do, but basically when maintainers don't want to maintain packages anymore, or they can't, Hero Devs will step in and be the end-of-life partner. So you'll see that in Vue 2. While Vue 2 is end of life, Hero Devs has decided to partner with Vue and continue to support it and do back patches, security fixes, and stuff like that, which basically means that the product is tests and build systems, which is something I'm very good at. So it's a very niche role, but everything from Lodash to Moment, we just signed with OpenJS, so jQuery, Bootstrap, all that stuff is in scope for software we maintain in perpetuity. It's a really interesting problem to be able to support such a wide variety of existing software. So I'm pretty stoked. I started 3 weeks ago.
Wow. So yes, I'm sure that you are overwhelmed with stuff to do, especially the beginning. It's always like that. But I'm curious. Yes, I want to know more about that. And yes. So what is this talk about?
This talk is about how to test anything. It pulls from my previous experience as a QA engineer, all the way through my experience working at Cypress and leading the development of the Cypress component test runner. And QA has followed me wherever I go. I happen to have opinions about it. I don't particularly like testing, but I guess I'm good at it. So this talk is going to teach people.
This might be a famous quote. I would say so. So yes, thank you. When you want, you can try to share your screen, and then you have about 25-30 minutes.
Okay.
And of course, best of luck.
Awesome.
Let's see if I can find
the odds
it. You share it. There should be a button like present.
Okay.
Marcus, thank you for still helping in the YouTube chat.
Let's see. I like him. Everybody knows each other. If people don't know this, people are like watching. Everybody knows each other. I adore working with him. So okay, sharing the screen, presenting. Share screen. Sharing is easy with 2 monitors. I don't have 2 monitors. Oops. And perfect. We have an existing.
Okay.
Cool.
Perfect. So
is this on?
This is correct. Okay, perfect. Right. I remember the title was how to test almost anything. So I'm joking. Best of luck. Best of luck. Right.
So how to test almost anything. And as always, it depends on what you're trying to build. So this talk is about answering the it depends that people ask me whenever I go up on and give a presentation or a workshop. Somebody will come up to me inevitably and say, hey, I have a very specific business. I ship this kind of software. How do I test it? How much should I care about testing? And my answer to them is always, it depends. And in this talk, I'll talk about how to properly care just enough about testing for your business needs and where to integrate it and stuff. So I gave this introduction just now. I think the one thing I missed, or 2 things I missed, is I'm a new TC39 delegate, and I'm interested in how JavaScript ends up approaching mocking and ESM stubbing. So things that vtest gives you are not part of the browser standard. We're wondering, how do we make these kinds of problems part of the browser standard? And you'll find me around the Vue, vtest ecosystems. I realize that I'm now the sole maintainer of the no longer supported versions of Vue 2 and 2.7. That's kind of exciting. So I'm in a situationship with testing. It's something I've done a lot of at every single company. I've built test runners. I'm about to build my 5th test runner. It's completely custom for Hero devs and the wide problem that we have to solve. I've done everything from manual QA to medical devices where I'm dipping a thermometer in a water bath and making sure the mobile app is correctly reading a temperature. I shipped that to a physical Apple store. It was a hardware software product. So I've done quite a lot of weird things. I've deleted entire suites of tests that were running on hundreds of millions of page views just because we could use observability and monitoring instead of unit tests. And so the ways that I approach quality and testing are not always write more tests. It's add the right quality processes for your business. So while I know a lot about testing, my first instinct is never to write tests. And I want to explain why. So earlier this year, I read a book called How to Test or How to Solve It. And it's a book that's incredibly famous in the mathematics and physics world. And it breaks down what you or other good engineers might do subconsciously or reflexively as part of your workflow. It breaks that down into discrete steps. It was written in the 1930s. And it is still a phenomenal book. I highly recommend, if you don't even listen to the rest of my talk, go buy this book. So I'm terrible at breaking things down into measurable steps. I am very much a vibes-driven development kind of person, which is not scalable and has lots of problems, but it's helped me so far in my career. And so as I was writing this talk, I was like, maybe I should work on that. Maybe this is an opportunity for personal growth. So here are the 3 discrete steps that I follow when trying to build quality software, no matter what the system is, with it web dev, if it's a thermometer that I have to make sure works and get signed off to the US FDA. So first is determine the process. What are the requisite inputs to how you will test the thing, right? Do you have to have a water bath to put the thermometer in? Do you have a website that is accurate to load your code on? For example, if you had to build Sentry, if you had to build an observability and monitoring platform, you don't necessarily have your own website. You're running on somebody else's. If you're building an advertising solution, you don't have your own website. You have somebody else's. If you're building a CRM app, things are very different, right? You have your own website. So very, very different situations. And those are going to be the inputs to drive what tests you care about and what tools you pull from in order to ship this quality software. The second thing is once you know what you need, right, you can decide what tools to choose and to progressively adopt them. This is what I call building the harness. Sometimes it's a literal test runner, sometimes it's not. Finally, execute and integrate. This is where you maybe expand the scope of your quality control process onto the rest of the team in the organization. So as you're happy, as you become very comfortable with the process that you've defined and the harness that you've adopted, you can then ask your teammates to start, very simply, writing a unit test, write your hello world test, make sure that the checkout flow works. You start inching into the technical decision you made on how you're going to test. And you start actually writing the tests or deleting them and adding observability, other kinds of tactics we'll talk about. So the quality control process is what I previously called it depends. And the dream with any system, right, quality systems are no exception, is that after you set up a process that works for your problem area, everything is just perfect. It's not. Like, no system is perfect. So you have to iteratively work on this, but it's good to do the self-reflection ahead of time. So you don't jump into tooling before you understand before you and your team and your boss are on the same page on what matters to the business. So understanding the business's needs with your quality control process. My indented, these didn't work. 1 second, I have to fix this because this slide is unreadable without fixing this. Risk colon. 1, 2, is it fixed? It is fixed. We're doing it live, sorry guys. Great, it was 4 spaces instead of 2. So risk, defining your company's risk tolerance. What's the worst case? What's the worst thing that could happen? So at my 2 examples I've been using, which is the medical company with the thermometer, the worst thing that could happen is you don't get an accurate reading on an infant when you're taking their temperature. That is the worst thing that could happen, right? That's why it's a medical device. It has rigorous testing. In advertising, the worst thing that could happen is you break the page of the company that is hosting you. So in our case, when I worked in ads, it would have been we broke Expedia. That's the worst case. But practically, the worst case is that nobody sees ads. And that doesn't really suck. Our users are just like, oh, my ad blocker must be working today. Right? That's the worst case for ad tech versus the worst case for a medical device company. Both of those things inform what the end quality process should be. And that seems about right to me. So recoverability, if the worst case were to happen, how quickly can you put that fire out? This really focuses on who's getting that phone call. Is your boss getting a phone call? Is Hacker News gonna at you a bunch on the things that you've messed up? That was more relevant when I worked at Cypress, right? Hacker News is a legitimate support forum for when you work in dev tooling. But for most people, this looks like support emails, right? And when you have support emails, how quickly can you resolve them? When I did hardware software testing for that thermometer company, one of the bugs that we ran into was a iPhone 7 bug, maybe iPhone 5. Whenever they switched from the plastic body to the metal body, because the hardware device had a conductive ring, it wasn't to spec. And when you would plug in the thermometer into the phone, it was a physical connection through the aux jack, actually. When you would plug the thermometer into the phone, it would send an accidental signal that would trigger the microphone. And the way the thermometer worked, that was considered noise, and the thermometer just didn't work. If you plugged in the aux jack into the phone at just the right speed, it would break the entire process. It took a long time to figure it out. It's the story of my favorite bug ever, actually. That was the U2 the U2 album that nobody wanted started playing. And that's how we figured out the bug, or I figured out the bug. And the fix from this, the recoverability of this, was every inbound support request I got, I had to send out mail. I had to send out tiny paper spacers that gapped the aux jack of the thermometer and the phone, the iPhone 5, 7, whatever it was. So the fix for this kind of an issue was a pain. Delivery and distribution process. When do we need to know when things go wrong? When something happens, how do we fix it? That depends a lot on the kind of software you're building. For a lot of us, it's for a lot of us, it's web applications. But for things like operating systems or mobile applications, this release cycle can be weeks long and involve many gigabytes of data. In web, we can move fairly fast, and as long as the cache is eventually cleared, users are cut over. Next, product lifecycle, context dependent. This is the needs that for what your team is working on. So I'll get into that in a hot sec. And practicality, given that time and money aren't infinite, how do we create a system that provides an appropriate level of risk mitigation? And this is where people get hung up often when figuring out like what unit tests to write. They're like, do I test every permutation of a string? Do I test that it, there's a joke here. It's a QA engineer walks into a bar, orders a beer, orders a beer, orders 2 beers, orders a kebab, the bar blows up, something like that. So making sure that appropriate level of inputs are tested, nothing too crazy, but reasonable. So this is the practicality bit. So risk. When I wrote this list, I was thinking of different business verticals and the different kinds of care you might take. So on the high order of, so low risk tolerance, payment systems, right? If something goes wrong with a payment system, a lot of things are bad, right? Those need high level of testing and high level of quality assurance. At the bottom, games, right? And this is actually in no particular order, but at the bottom you have games, like what's the worst thing? Oh, Candy Crush messed up a level. I wouldn't particularly care about that. They can patch the game, and yeah, there's some user trust lost, but honestly, it doesn't matter. Calendar apps definitely matters. I would say social media features, it depends. But these are the different kinds of business verticals that have different it depends answers. Recoverability, how technically difficult is it when things mess up to correct them? Right? I mentioned earlier, mobile applications and operating systems, those can be expensive. You can make things like mobile applications and operating system updates less expensive. You can do that by adding certain features we'll talk about later, like feature flagging, right? If you've heard of Launch Darkly or Growth Book, one of the things that you can do is add feature flagging in order to ship code in production, but turn it on conditionally when the product is ready for it. And you can turn those things off and on. So if there is a bug that you detect in production that you either didn't test it well enough locally or couldn't at scale, you can find out about it when you launch and quickly roll back, right? So websites often can do feature flagging, but definitely don't need it as much as things that move very slow. Or have things that are irreversible. So for example, data storage, large-scale distributed systems, the rollbacks on those things are very different from things like web apps. So we actually have it fairly easy in web app land. So delivery and distribution process. Would anybody notice if something went wrong, and who's getting a phone call, right? The support team, generally, the sales teams, like those are where you're going to find out about issues if you haven't caught them in development. I like to think of those phone calls whenever I decide if I'm going to write tests or not. And then your abrasive teammate at the bottom. If your quality control process is too onerous, who's going to tell you about it, right? So who's going to be upset that the squiggly lines in your editor don't work when you're using it and describe that person? Just think of them when you're developing the rest of your process. So finally, or almost finally, product lifecycle. Are you in the heat of building a new feature? Are you in a high risk or critical spot? Like, let's say you're trying to close a deal, or you have an existing partner that you really can't afford to lose, right? How do you make sure you don't break their stuff in particular, right? Or you just don't touch features until things deploy. Ideally, you have a quality control system that enables you to ship continuously without fear, but sometimes it's just better not to touch things if that doesn't exist. And that is a legitimate strategy, right? Like not touching software if you have something critical is a very legitimate strategy. It costs time and velocity. Like it has a cost. However, not touching a thing is completely valid. You can also think about things like, does your product need ongoing maintenance? So in the absence of, so this is really relevant for software companies and agencies that do contract work, right? So if you're never going to have to look at that code again, this is partially why sometimes contract work and agency web apps don't look like production code and systems that you might have in a long-running product. If you are throwing the code over the wall and saying, I built the website, it ships, I'm the only person that's going to have to maintain it in the future if they ever want additions, you can decide to forego a testing quality, like a continuous system, like unit testing, right? You can decide, I don't want tests. I don't want automated testing, because the deliverable that I'm giving to a customer that pays my check is, does the customer believe that it is solid? And two, am I confident that I integrated payments correctly? Right? This is your own risk generally that you're taking on, your agency's risk. It's completely valid to do a full regression suite at the end of the delivery cycle if you're the only developer working on it, and you will always be the only developer working on it. Conversely, let's see. Yeah, incrementally improving upon an existing system and trying to maximize its value. If you're a Google or an Amazon and you're building YouTube, let's say, you heavily use feature flagging. You never make large sweeping changes. Everything in Google is feature flagged, actually, in Google's development. And you're just looking at those bottom line metrics. With enough volume, you can say, all right, we turned the feature flag on for YouTube's feature, and we saw the total viewing hours go up. And that is your quality metric. Like, regardless of what you've experienced as a user while using the application and the new feature, the bottom line quality metric is, did people watch more YouTube? And is that range about where we expected it to be, right? If you have great deviation in that bottom line metric, you probably have a quality issue. So the practicality, finally, what's necessary in order to meet the product where it's at, right? Thinking about those high velocity situations versus the time where the product doesn't need to change very much. And how can you deliver enough confidence to meet the business needs? So when thinking of practicality, the thing that people initially lean towards when building web applications in particular, and they're pushed into this by, usually pushed into this by product or founders and people with high needs and low experience in the pain that it costs. A lot of founders will say, okay, let's test all of the browsers because I don't want anything to go wrong ever. And an engineer that's implemented cross-browser testing will say, that's expensive and it's going to slow me down a lot and you don't need it. And the third one is where I'm at, right? You don't need to test every single feature in every single real browser because the majority of issues you will catch are far before that. And it's much, much cheaper and faster to do it that way. So practicality is, given that money and time are an infinite, how can you solve the problem and gain the confidence you need at the quickest and cheapest part in your process? So I would say a lot of us, tend to, I don't know if anybody's talked about the testing pyramid today yet. Probably they have. I'm going to make that assumption. But as you fall lower and lower down the testing pyramid to unit test level, right? That's where you want to catch the majority of your issues because it's more expensive to, at the peak of the testing pyramid, test it yourself manually, right? That's the most expensive thing, is to fire up your browser and go through every single installed browser on your computer and do it manually. That's the most expensive you could do. So ideally, you have a computer figure it out way, way before you finish the feature and you have to run it across a browser, right? So next step. So after you're happy with the process and your team and you understand the bounds of what any quality control approach needs to have, right? What things can you not negotiate on? right? If you're a medical device versus if you're shipping a video game, what things are non-negotiable? The harness concerns when things happen and why. So the first thing you'll probably see is CI to run your unit tests. It's fairly fast to get done. And then you'll try to decide, when are we going to run those tests? Are they going to happen nightly? Are they going to happen on push? How about on merge into main? Selectively, depending on the area of the code base that was affected. This is that third one is very popular in a lot of build orchestration systems. You'll see that. That's how Google does it, right? They have just so many tests that they selectively look at the code, see where it's used, and run it like that. Most front-end test frameworks don't. A large majority of front-end test frameworks that you'll see don't do this. It's not usually necessary, I don't think, but it's a tool you could choose. Next thing would be, okay, now that CI is running my unit tests, I would like to catch issues before they get to CI. So that makes me work faster, right? There's the velocity improvement of having local dev tooling, having your unit testing run on your computer, having the ability to execute things like Cypress or Playwright locally. After you figure out, okay, I can develop and run tests locally and in CI, and I get a little green check mark if I didn't break anything, you can start to add more types of testing that fill in different gaps and risk that your business and product has. So this is things like API testing. I highly recommend people Google for a second QA testing types, and you'll find about 20 different testing types that you've never heard of, like performance testing or load testing, and each one of those things is important depending on the kind of software you're building. But for the majority of people, they want to do what's called functional testing, which is the unit integration and end-to-end testing of, like, as a user, when I click through this flow, I should get, a cart filled with products. That's functional testing. And let's see. Yeah, you have infrastructure level tools. I talked a little bit about it, but basically avoiding work, which is how I like to call this, is can you use things like Sentry to do error logging for you and do observability and figure out what issues exist that way. For example, I had to support IE8 way past its due date. Like, I had to support IE8 when it was really unsupported. And we would use CSS features accidentally that didn't work, but they would break in weird ways. And instead of somebody loading up a Windows VM that's ancient, right, with IE8 on it, we just used observability and flagged, like, this person clicked on an ad, for example, right? We have a downstream bottom of the funnel metric. And if on IE8 that number dropped, by a few million, we would say, we messed something up. And we integrated that with canary deploys to be like, all right, 50% of our traffic is here. And whatever you did just broke this one weird slice of the population that we care about. That's, money that we frequently break. That's the other thing, the it depends nature of the problem. It's like, based on the issues you've had inbound into support, into sales, what things usually break. Technically what's difficult to support. IE8, if you have to support it, this has changed since then, but if you have to support some obscure platform, for example, targeting that and using something that isn't manual and is data-driven is a decent proxy for having to write automated functional tests or manual. Open Windows VM, click onto IE8, make sure that CSS works, that kind of stuff. So avoiding tests is a great strategy. Finally, executing and integrating. This is when you need to see that the harness and the values that you've all agreed on work for you, right? Are you getting any gains? And doing those things can happen in the same time. You don't have to build this overbuilt quality pipeline that you're just fixed and, like, not changing on, right? You don't have to be stuck with anything. It's just software. It's just a system. And so adopting incrementally and tweaking it incrementally as you use it is going to be the way that you are happiest. And you're going to get the most value, because you'll find that if you don't want something, right, as you're adding tests for the first time, if you don't want something, if you're not reaching for some tool, then maybe you don't need it, and maybe you shouldn't build it. So doing this in stages, doing this in a cycle is going to make it so that your system doesn't become unwieldy and unnecessarily like thick and resilient. And once you're happy with that, bit by bit, you can start to farm out the work to the team and say, okay, when you put a new PR together, I expect you to have written new code, for example, in TypeScript. I expect your new code to be linted. I expect your new code to have tests. Yeah. That's when the magic happens and you're like, all right, we have a linter. It's catching linting issues. Nice. We have TypeScript. It's catching static. It's doing static analysis and catching type errors that I would have had to write unit tests for. But now that we have this file in this other type-safe language, we don't have to write unit tests for it. I don't want to. OK, that's what the end-to-end tests are for. I'm not going to get into that. But if you had that question, you still cover it. You still cover it, but you cover it with end-to-end tests. Anyway, I think that is my final thing is use people. So your system isn't perfect. Quality control system is no exception. And it's better to acknowledge that and do discovery work to understand what you might run into in the future and what your risk tolerance is. So everybody at the company is on the same page. And then fill those gaps with creative solutions other than code. We want feature flagging. We like people, manual QA. Believe it or not, people can perform the same jobs as computers, right? We used to be called computers in like the 50s. And you might have written tooling for it or decided to automate it. Like, here's one that I like, dictionary checking. I've never integrated it into a CI pipeline or a build step, but I really like typo checking. It's just too expensive to do. And so I always get it at the PR phase. I think sometimes about writing tooling to put it in the linting phase, but I don't do it because I'm not annoyed yet. So when I get annoyed with a kind of quality problem, I find myself like finding the same issues over and over again. I think, how do I solve this? Do I solve it programmatically? And actually in this dictionary case, I had a teammate where English was his second language. And I guess I'm giving a Europe-focused talk right now. So I had a teammate, he was French, and he had a lot of typos, which was like fine, right? But I was like, hey, install this VS Code extension. It's called CSpell. And he did that. And I never had to fix a single typo again in GitHub PR suggestions. So creative solutions, first do it yourself, then say, is there a tool that can do this? Is there a tool that can do it cheaply? That's what I have. My takeaways are determine your quality control process, spend a lot of time on it, build a harness to do it, and execute and integrate that quality control process with the harness. Don't over-engineer your test harness. That's what I have today. Thank you very much. You can follow me on Twitter or Discord. Yeah.
Perfect. Thank you so much, Jessica. Let's go quick, but I like to say that it's nice that you said humans can do the same job as computers, because we were used to say the opposite. Computers can do the same job as humans. Now we are saying on the other side. Okay, so we have some questions. It is you talked about feature flags. I don't know if you answered this question during the live, but Massimiliano asked, like, in feature flags require a single point of change, and what about A/B testing? I don't know if you already answered this.
Yeah. So I've done, at my ad tech company, we abused our A/B test system to act like feature flagging with 0% and 100%. So you can also use A/B testing as a 50% canary situation in which you're like, yeah, I'm positive that, so there's things that you know work, like red button, blue button, that kind of a thing. But there's also stuff that's like, this code looks dangerous, or I don't really know. Yeah.
Okay, and we have just a couple of questions by Yunei. Enabling a local development workflow, we have a really painful way to seed the DB, and this puts devs off. They don't want to run tests locally. Techniques for this.
So keeping in the spirit of the talk, it depends on how painful it is and why. I would consider figuring out how to not run a database locally unless something fails in CI. If you have to solve this problem, you do it at the infrastructure level with a lot of Docker image caching, ideally shared Docker image caching, and trying to make sure that your tests aren't mutating. So ideally, that kind of a solution. But really try not to depend on that for the majority of your stuff, right? Use in-memory databases when possible, mock out API requests. You're looking for those cheaper seams in order to get the same confidence and coverage without having to do a big infrastructure push. Like, does your harness need to change, or can you change your process? That would be my question.
Thank you. Last one, really quick. We often use feature flags. Sometimes the state is changed and other won't know about it until it breaks in an end-to-end test in the pipeline.
Yep.
How can we prevent this?
You mock out the A/B test service. I would never run, or you can make a particular bucket. Like if you didn't want to change a lot of code, right? A lot of times we're in these systems that already exist. If you didn't want to change a lot of code, you could go and you could make working with the hack, right? You could go and you could make a special bucket that's like the test runner bucket. And that thing would generally have the same settings, and you remove the randomness, but you don't break out of the system. So it's a little janky for sure. But that's living in the code base that you're already in versus saying, yeah, we shouldn't rely on randomness at all. Let's mock out the A/B test service. That's what I would do in a healthy code base where I had time. I would mock out the randomness for test only.
Thank you so much, Jessica. Really appreciate it. Really enjoyed your talk. I love that you fixed something like in production super quick. So if you want to stay, I invite you again in 30 minutes. Otherwise, no worries. Thank you so much. Now it's Filip's turn. Thank you. Thank you. Bye. Filip, we made it. We are here almost at the end of this episode. I would like you to quickly introduce yourself, a trailer of your talk, and then we'll just start right away.
Yeah, thank you so much. Happy to be here. Thanks for the invite. My name is Filip. I teach developers about testing and testers about web development. And that's what I'm hoping to do as well today. I work for a company called Replay.io, where we help you with your flaky tests. And I see you're all hooked up with the stickers from last week. That's great. I forgot to put on my hat, but hopefully a replay will be mentioned enough for you to notice. So yeah.
Perfect. Thank you so much, Filip. When you want, you can share your screen. Usually you have 25 minutes, and of course at the end we'll also pick questions. So don't be shy for this. And of course, Yunei said thank you for this. Best of luck, Filip.
Thank you. I'll be looking out for those questions.
Right.
So feel free to ask them. Feel free to leave them in the chat. I'd be happy to answer them at the end of the day. At the end of the talk. We still have a lot of day left. All right. So as I said, I work for a company called Replay, where we built a time-traveling browser, and I'm going to show it to you in a little bit. But before we start today's talk, which I called console.log, Debugging the Modern Web, we're going to be using console logs during my talks. I do have a couple of questions for you, which you can either try to answer in the chat if you feel like giving a thumbs up or a comment, or you can just answer them for yourselves. Usually I do this before I start my talk. So my very first question is, are you writing end-to-end tests? And I'm going to go ahead and jump to assumption that you do, since you are on this talk. Probably you are interested in this whole event of some great speakers before me that talked about testing end-to-end tests. You probably do that. Has your end-to-end test ever failed? As they say, never trust a test that you haven't seen fail. So hopefully you have. But let's now move to the more problematic side. Has your ever test failed and you weren't sure why? What happened? If you answered yes to that question, I have another follow-up question for you. Have you ever spent more than 1 hour trying to debug your test, especially if you ran it on a CI, but locally it was working fine? What's going on? Not sure if you were in that situation. I have definitely spent a lot of time dealing with that kind of issue. So let's ramp it up a little bit. Have you ever spent more than 2 hours debugging? Or maybe more than a day? Does that make you sad? Hopefully it doesn't. And I hope I'm not resurfacing some trauma or of sorts. But if you have answered yes to those questions, especially to the latter ones, you may have experienced the frustrations that come with UI end-to-end tests. And this presentation is about possible ways of reducing those frustrations. So let's dive in. So I'm risking that half of you will leave right now, because this testing pyramid, this scheme, you have already probably seen lots of times. It's probably repeated in almost every testing talk. At least I see it very, very often. So, but please don't leave. As I mentioned, you probably know this model. That we have end-to-end tests at the very top. We have unit tests at the very bottom. Unit tests being fast and cheap. End-to-end tests are being costly and slow. But I have to say that I believe that this model is very outdated. Nowadays, we have much better tools. Some of them were mentioned today, right? We have Cypress, we have Playwright, and many other great tools. So especially the cost of creating a test, you can just spin up your test really fast, is not so high anymore. And as a result, we do tend to have a lot more of these kind of tests. But let's stop at this little guy who was at the top of the pyramid, the turtle, right? Because as I said, we have some great testing tools nowadays. But they all seem to focus on one problem, right? The speed of execution. There's a race between different tools, like which one is the faster. And I have read countless of blog posts comparing Playwright and Cypress and maybe some other tools. And what they do is they oftentimes focus on the test execution. But the truth is, if you answered yes to any of those questions that I have asked at the beginning, you know that there's a difference between speed of execution and the speed of maintenance. And when I recently asked on LinkedIn, how much time do you spend writing tests versus maintaining tests, or rather, what takes a bigger part of your day? An overwhelming majority of people have answered that debugging those tests actually takes a bigger part of their day. And it's kind of funny because sometimes we don't notice that debugging is the thing that actually takes more of our time, right? For example, when it takes 30 minutes, which is a lot, to run your tests in a pipeline, we as developers, we are happy to spend a month of our time migrating from one testing tool to the new shiny thing, so that we can in the end take it down to 25 minutes. You know what I mean? We do all this work because we believe that maintaining end-to-end tests is just too much work. I think we're mentally still kind of living at the top of that pyramid. But to be completely honest, I think in many ways we are really living in the top of that pyramid. Because how do you deal with flaky tests? We have these so-called strategies to help us live with the fact that our tests are flaky. And I've seen these strategies across many companies that I have worked with or consulted with. And those include things like muting a test, quarantining a test, retrying a test, maybe adding a longer timeout, trying to reproduce a test locally, deleting a test, or, as I like to call them, shock, denial, anger, bargaining, depression, and acceptance. That's a little joke for you there, but it kind of it rings true for some reason. As they say, these strategies exist because we have limited visibility in what's happening in CI. It's no longer what happens in Vegas stays in Vegas. It's what's happening in CI stays on CI. Many times, and that's because we cannot really observe what's going on there, right? And we have these different strategies of how to pick things from there. And oftentimes what happens, we're sort of left with only a message or a short message of what the result of the test was, right? And I think that the main problem when dealing with end-to-end tests running on CI, being flaky, giving you different results locally versus in the CI, is the lack of context. Because end-to-end test usually copies a user story. When an element is not found, it tells us nothing about what exactly has happened. In fact, when a test ends up with an error like this, the problem that caused this error might have happened a couple of steps before, right? You don't find an element, but the reason for why you haven't found the element was that because you weren't able to create it. So I want to share with you a couple of stories that started with a mysterious message like this, and these are stories that I either encountered personally or with our clients at Replay. One of those clients is Metabase. Metabase is a business intelligence software. And what's really beautiful is that they are open source. So I really recommend you, if you want to see how a large test suite looks like, you should check them out. And we were helping them drive down their test flakes. So they have hundreds of end-to-end tests, and they had quite a bit of test flake. But then with the integration with Replay, we were able to drive it down to practically zero, or zero on a main branch, as any new flakes that were introduced with a release branch or feature branch could be fixed quite quickly. Yeah, all right. So here's the first example: a missing spinner. It's a fairly simple test. We wanted to make sure, the team at Metabase wanted to make sure that users that have a slower connection know what's happening, that there's a resource being loaded and that they need to wait and see that spinner animation happen. But this test started failing, and it was failing over and over, which was strange because none of the code that it was testing has changed. And this is really frustrating for developers, right? And for testers as well. You run your test, and for some reason, they just start failing. So we have recorded their tests with Replay browser, which would capture everything that was happening on CI, and we started debugging. So what you see here on this animation, actually this should animate, and I don't understand why it's not. Maybe let's refresh that. Is it going to work? No, it's not. What if no? All right. Well, we don't have an animation. We just have a image here. But what you're looking at is Replay DevTools. So we pulled the recording of our test from the CI and opened it up in this DevTools. On the left side over here, I'm going to highlight this for you. We see a indication of how many times this exact line of code was executed. It says 27 times. And if we were able to see the video, you would see that when we run through these executions, we can actually jump into any one of these executions. We would see the spinner element clearly appear. I'm sorry. So the problem is that the spinner element clearly appeared. It was not gone from our application, but the test that was trying to test it was not fast enough to catch that element. And this is what made the test flaky. But Metabase team was smart enough to think about this. and they have implemented this throttling strategy. They would capture the API call that would be loading those resources from the backend, and they would throttle, or in other words, they would slow down the request by limiting kilobits per second, which is really smart. But there is one catch, and that's the response from this URL. Because this test will resolve in different time if the response has 100 kilobytes or when it has 1 megabyte. So in the end, what happens is when the response from this URL is smaller, the test will run faster. And what that meant for our test was that the spinner animation would show for a shorter period of time. In fact, it showed for such a short time that the Cypress test, was not able to catch it. So in the end, the solution was quite a simple one to make the test stable. Instead of set throttling, they would set up a delay, and this way the test would be fixed. All right. And this was larger, the fact that we were able to find this was largely to the fact that we were able to time travel to that line of code. And we were able to record our tests on CI and bring those recordings back to Replay DevTools. If you're curious, the integration is really simple. Since Replay is a browser, you can just use it instead of Chromium, and you will have your recordings available in an online dashboard. So here's an example of how you can integrate that into Cypress, Playwright, and we also support many different test runners like WebDriver, iOS, Selenium, Puppeteer, or Jest. Because it's just a browser. With Cypress and Playwright, there's also a plugin installation, but I'm not going to get into the details right now. All right, another story. This is a fun one. It was a problem with visualization, another flaky test, and I'm just going to go ahead and show you a screenshot from a failing and a passing test side by side. So one screenshot is from the passing test, and and one screenshot is from the failing one. Can you see the difference? I would be really, really surprised if you were able to tell, especially since we're on the live stream. But if you do, you have amazing eyes, and I would like to talk to you. I have a video that highlights it, but since videos are kind of not working for me right now, I'm trying. It's kind of a bummer. You know what? I'm still going to try to refresh that. No. Let me give it one more try, and we'll see if we can make it work. Nope, no videos today. That's unfortunate. I thought this is going to be solid. In fact, if you're ever doing a live presentation, make sure you have a backup video for your live demos. But it seems we're going to be relying on live demos today instead of videos. Well, unfortunately, I cannot really show this to you now, but I'm going to tell you. There was a font change that caused the test to fail. So this graph would have a font on the sides and at the bottom, and it would slightly change. So there was an update, a CSS change that would make the font have slightly bigger weight. And what would happen there is that it would shift the graph. Let me show you how confusing that was at the beginning, right? So there was an error message at the beginning of the investigation. There was nothing that pointed to a problem with CSS or that the font have changed. In fact, it really looked like a functional error. The error said that it is expecting a certain text, a certain date that started with April 1st. But when it failed, it says, oh, it actually showed May 1st. So there was some kind of weird issue with that. To give you a better idea what the test did, what the intention was, here's the test code. So the test tried to select a range. It would click and drag and drop. This would be done with a series of Cypress commands. It would click on the visualization graph. It would put its mouse down on certain coordinates, drag it, and then move the mouse up, basically performing this drag and drop action. And then a validation would be made in order to make sure that the proper range was selected. And a good place to look when bugs like these happen, when we have a mismatch in what the expected text is to take a look at the network panel. And since we recorded those CI runs, we were able to look into the network panel and confirm that the range that was selected was indeed May 1st. So it seemed like the application did behave the way it was supposed to, but there was something strange with the text. Our test was doing something we did not expect. It didn't behave the way we wanted. So going back to the video comparison, which you cannot see, you might, if you saw that animating, you would see that there's this light blue rectangle over here. And this would stay in place because Cypress had command coordinates to where that drag and drop action should happen. But when the font caused the whole graph to shift, those coordinates would change. So since Cypress commands relied on precise coordinates, they would select something different. And indeed, they at the end would select the range that was April 1st and not May 1st. So that was kind of a fun one. All right. Story number 3 of a test flake and debugging story. If you're doing testing, there are chances that you have already seen an issue like this, a race condition that causes the test to be flaky. Here I have an example with a e-commerce site that sells a sneaker. I have a Cypress test that is trying to attempting to buy that sneaker, and it is flaky. Sometimes it fails and sometimes it passes. And when it fails, it seems like we're clicking on the button too soon. This would be indicated by multiple ways. We don't see the proper message, the success message, but we instead see the error message. And at the moment of the click, if we take a look back into our timeline, we see that the counter that shows the number of sneakers shows 0. We were trying to fix the test, right? We added a wait so the test does not go too fast. But this is sort of a anti-pattern. You don't really want to add waits for in your test. Maybe you do, but there are situations for this. This was not the one. In fact, it was kind of a slippery slope because we may be increasing that time, but not fixing the real problem. And the real problem could really be happening to a real user, for example, with a slower connection. So let's debug this together. We're going to dive deep into the code and figure out what it is that actually made this test flaky. So let's recap. What do we know about this? Test opens a page and clicks Add to Cart button. This test sometimes passes and sometimes it fails. The error says could not find text product added to cart. So product added to cart is the success message which we cannot find, and the test fails. Counter shows number 0. The test seems to click on the Add to Cart button too soon, and our test fails locally, passes locally, but fails on CI. So let's go ahead and debug. So I have a replay of this test, which I'm now going to show to you. And this is a test that happened, that was running on CI. Here's the test definition. I have a couple of tests here, and I have a failed test, and then I have a passed test. So I can play these tests sort of like a video and see what was going on. And you can see the first test is sort of failing. We see the error message, and then Cypress will run that test again, and this will make the test pass. So I can go here and try to examine what's going on in the failed test first. So I can see all of the commands that were executed here, and I see that there's some sort of error. There's some API that's not working, right? But before those happen, I have a click action. I'm clicking on this add to cart button. Now, as I hover over this action, I can click to jump to code, and two things will happen when I do this. First of all, it will open my DevTools, and second of all, it will take me to a product detail component. This is a component of my application. So when I'm jumping into code, I'm not jumping into the test code, but I'm actually jumping into the application code or the exact line of code that was executed when I clicked on that add to cart button. I'm going to hide this side panel right now, and I'm going to focus on this component because this is actually interactive and can give us a lot more information. But let's read this first. So this function that was called when I click on add to cart button is a function that calls this add to cart API call. It uses the fetch to call this API add to cart. Now I can see the method, the headers, and I can see the body, which is sending this QTY or this quantity variable. Now, I have another API call here in this application, and that's up here. It's called fetch availability, and that one is checking that availability. So this is the component. It is calling two API calls, and I can see how that was executed when I was in when the test was running. I'm going to network panel and try to filter out all of the fetch XHR request, and I can see there are a bunch of API calls being made. This check availability, which basically checks all of the sneakers that are available, and then this add to cart. Now, this add to cart is where this fails. In fact, if I take a look at the response, I'll see the message, cannot add 0 items to cart, which is the exact message that will show up when I click on that button way too soon. So it's kind of a strange one, right? Why do we want to add 0 items to the cart? That's probably not our intention. We want to buy a sneaker, not have 0 of them, right? So what we can do is we can double check what this add to cart function was doing, what kind of body it was sending. We can do that at 2 places. First of all, we can take a look at the network panel on the right side and take a look at the request, and we'll see that the quantity is 0. But the cooler thing that we can do is we can look directly into the component and print out this quantity. I'll add a plus symbol over here, and this is like inside of brackets of console.log. So what I can do is type quantity, confirm, open my console, and I'll see the number 0. Now the interesting thing here is that when I go back and take a look into both of my tests, that console log is being printed out for both of them, right? So if I change it now and change it sent to the server, let's give it a purple color so it's nice. We can now see those differences between the failing and the passing test. So in the failing case, we're sending number 0 to server, when in the passing test, we're sending number 1 to server. So that's kind of interesting. So let's examine a little more. Where does this quantity come from? Well, since I'm exploring my source, I can just go Command F and try to find where this quantity is being used. And besides being sent to the body, I'll see that it is a property of my counter component. I can also see my add to cart button component. And if I scroll up, I'll see that it is using a state hook, which by default is 0. And then I see a set quantity function that mutates this state. And that one is being used over here. We set the quantity to data QTY. So what is that? Well, it's coming from data, which is calling this fetch availability function, which is the function that checks our availability. So I sort of went backwards here, right? So when we fetch availability, when we want to check how many items we have on the server, we return that response. That will get fed into this data object, and quantity attribute from the data object is going to get set over here. So I'm going to add another console log, just as I added over here, and I'm going to print out data qty, so I can see what that is. I'm going to give it a green color and add a annotation here. So data, or let's do availability fetched from the server. Let's see what that shows. All right, so now I can see I have two console logs. I have another first one and the second one, and I see them printed out over here. So we sent number 0 to the server, but availability fetched from the server was 1. Let's go back and try to compare our failed test to a passing test. And if I go to the passing test, I can see that both of these are number 1 in that case. If I show them side by side, I see an interesting thing. Look at the order of how those console logs are being called. This actually indicate how what was the order of each of line of code that's being called. So what we have here is we have a race condition. So in our failing instance, we sent number 0 to server, or the default value of our quantity, before the availability is fetched from the server. In our passing test, this happens in reverse order. So we successfully fetch everything, and then we send that to server. Now, this would be incredibly hard to find if this was only happening in CI, which was the case. And it was happening in CI, but since we recorded this with Replay Browser, we were able to find the problem. All right, let's go back to the presentation. So how do you fix that? How do you fix the problem? Because we already attempted to fix the test, right? We added the CY wait and waited for 1 second to hopefully fetch all the data from the server, and that way we can make the test stable. But this is not really fixing the real problem. So let's fix this properly. Let's fix it in the application code. So here I have a parent component. We saw this. We have this counter, which counts the quantity, and we have a add to cart button. So we're going to add is disabled property to the add to cart button. So if the quantity equals to 0, that quantity is going to be that property is disabled is going to be set to true. We're going to add this to our button as well. Sorry, my emails are annoying, so I'm going to turn them off. Just going to turn off the volume. All right, and then we're going to add a HTML attribute to our button as well. So is disabled is going to be equal to disabled, right? And then we're going to add some styling so that the opacity of the button is semi-transparent. Now, once again, my video is not really playing, but as a result, what you should see is our code becoming much cleaner. So in this instance, what would happen is we would be able to remove our wait from our Cypress test, because Cypress automatically checks if a button is disabled. So while the data is still fetching, that button would not be clickable. So you could argue if this is the best solution, but it's definitely the one that would prevent our users from trying to add 0 items to their cart. It makes the test automation much more stable and therefore more reliable. And I'm very confident that more than 90% of what we usually call flaky test is actually a flaky app, and it has nothing to do with the code itself. I think this is how your test should look like, ideally. I know there's a lot more happening in real-world application. This is more of an example, but I think that this is fine. This is what we should be aiming for. So these are just a couple of stories, but are definitely more that I could share. And here's the thing about test speed. We all want to improve test speed, right? That's why we sometimes find ourselves migrating to another shiny tool, or deleting our tests, or doing any of those coping mechanisms or flaky test strategies that I've shown. But obsessing over speed of execution is probably not the way. It is the speed of how fast we can debug our tests. And only by driving down the debugging time, we can achieve real speed improvements in our real lives, because we can also always add another machine to a CI, but we're probably cannot multiply ourselves to be debugging much faster. So all the flakes that I've normally shown you would normally take hours or days, but when you have the option to pull information from CI, as you can with replay, I think you can take it down to minutes. So hopefully you like this presentation. If you have any questions, I'd be happy to answer them. Sorry again for the video not working, but hopefully it didn't decrease the quality presentation that much.
Yes, no. It was great. I really loved the.
Oh yeah, sorry, I cannot hear you because I muted my sound because my email was coming.
Can you hear me now?
I
So
hear
you
you
you thought it was me muted, but it was your fault.
It was my fault. Sorry about that.
So thank you so much for your presentation. I think that Jessica really loved this presentation. She was very active in the chat, and also very nice jokes. Technically, I have a meeting in 1 minute, but it's okay. I think they can wait a couple of minutes. Maybe I don't know if Jessica wants to come up on stage again. We can have a quick, really quick thing. So thanks. Really enjoyed this presentation and the style and the thing, and you exposed that. I tried to grab a couple of pictures and share them. I love that the flaky tests problems solved. That's it. So yes, so thank you so much, Filip. Thank you so much, Jessica. We also had Marcus that had to leave. It has been a very long day for me, so I'm gonna call the day for today. But really enjoyed it. Looking forward meeting both of you again. I don't know, Jessica, what's your plan with conferences? But at some point we might.
I'll be in Paris. I'll be in Paris in 3 weeks at .js. So I don't know.
Okay, I'm gonna skip that. I will be in India in 3 weeks. So yes. But anyway, thanks. I really enjoyed your presentations. I don't know if the presentations will be available somewhere. Filip or Jessica.
I'll put it on the internet. I'll put it somewhere.
Okay, so just follow them. We leave the link of them below, so you can follow, and they'll probably share them soon.
Yep.
Thanks everyone for coming. Thanks everyone for joining. Thanks Yunei and everyone else here. And we'll be back in 3 weeks here again with the multi-dev event. We are done. Thank you.
Bye.
Thank you very much for having me.
I love that. Bye bye.
Bye everyone.
That's me and the stream.